Okay, let's do the solution to this part of the classwork. So a lot of people solved for the generic form for the parabola, which ends up being this. And notice actually this fits the connections in our last slide very well. So of course we have that the x-coordinate of the vertex is the same as the x-coordinate of the point. We'd also said that the y-coordinate of the vertex is halfway between the point and the line. And look what we're doing. We're doing b plus k over 2. B is the y-coordinate of the point. K is the y-coordinate of the line. This is how you find an average. So we're saying literally the y-coordinate of the vertex is the average of b and k, which is halfway between b and k. So that all matches. Let's do the actual questions I've asked, though. So let's use this general form to quickly write the equation for a parabola if the point is at 4, 6 and the line is at -2. So rather than do the derivation, we can just plug in those values for a, b, and k here, and just immediately get the equation for a parabola where all the points are equally distant from 4, 6 and y equals -2. So let's plug in. I've got y equals 1 over 2 times, and then b is 6, and k is -2, so minus -2 is the same as plus 2. Then x minus a is 4, and then b plus k, so that gives us 6 plus -2 is like minus 2 divided by 2. So there I've just plugged everything in, and then in one more step we can simplify. So that's 8 times 2 is 16, x minus 4 squared, and then here we've got 6 minus 2 is 4 divided by 2 is 2. So there we go. Okay, part B says if you're given this equation, use the equation above to figure out what a and b and k must be. So I've written down the two equations. There on the top is the generic equation for the parabola, and then here's our specific parabola that we're interested in. All you have to do is kind of line up the parts of the equation. So a negative sign here really is the same thing as -1. So here's some stuff I know. I know that -1 is the same as that part of the equation. So let's set them equal. B minus k. I know that 1 is the same as -a. I'm just going to write literally what I'm saying, and then we'll see what it means. And we've got that -11 fourths equals b plus k over 2. Okay, so this middle one right away tells us that a has to be -1. Here I have an equation with both b and k in it, though. So if I isolate b, it'll just tell me what b is in terms of k. However, I have two different equations with a b and a k. So I can just solve this as a system of equations. Let's do that. I'll multiply by the denominator here. So that'll give me -2 b minus k equals 1. I'll distribute in the 2. So -2b plus 2k equals 1. Over here, I guess we'll multiply by 2 on both sides and multiply by 4 on both sides. So that gives us -22 equals 4b plus 4k. Let's go ahead and divide by 2, actually. So -11 is 2b plus 2k. So here I've got a 2b plus 2k, and here I've got a minus 2b and a 2k. So what if I add these together? Let me write them stacked one on top of each other. So here I've got 1, and then the 2k, and then this is -2b. Okay, so let's add that way. So here the 2b and -2b add to be 0. These add to be 4k, and then this adds to be -10, which gives me that k is -10 fourths, which is the same thing as -5 halves. So we found k. Now we can go back and figure out what b needs to be. I guess I'll substitute back in, sure, why not, up here. So we had -11 fourths is b plus k, but now we know that k is -5 halves over 2. Let's multiply by 2. So that gives me -11 halves equals b minus 5 halves. Let's add the 5 halves. So if I had 5 halves minus 11 halves, pause and think what that is, should be negative 6 halves, which is the same thing as negative 3. So that was the idea. The idea was, if you like to sort of step back and think about the strategy, each of the parts of our parabola here corresponds to part of the equation here. And so I know we can set those equal. Sometimes that'll just give us one of the values right away. False sneeze alarm. Okay. Sometimes you might have to solve a system. So I guess let's actually write our final answer as it was expected. So what was A? So we've got a point at -1, -3, and then the y value is negative 5 halves. So that's our point on our line. Okay, let's do the last part. So finally, what if I have a parabola in general form, like this one, and I want to know what's the point in the line that all the points are equally distant from? One thing I could do is I could take this general form for the parabola, multiply it all out, and then I'd have this equation in general form. So I'd have an expression for the number of x squareds, and I'd have an expression for the number of x's, and I'd have another expression. And so then I could set the number of x squareds equal to 2, and the number of x's equal to 3, and so on. My gut feel about that is that's going to end up being more complicated. So instead, a really common strategy in math is to take a new problem and turn it into one that you've already solved. So we already solved part B. Could I make this general equation look like the equation from part B? And the answer is definitely yes. If I complete the square, that'll let me put this into vertex form. And then I can solve problem B all over again, just with a different set of numbers. So let's try that. Okay, so I'm trying to complete the square here. It might be very tempting to divide everything by 2. The problem is, if I divide everything by 2, the y also has to get divided by 2. And I suppose I could do that and then multiply by 2 again. Actually, let's do it both ways, since this is an educational video. So let's divide everything by 2. So I'll have y over 2 equals x squared plus 3 halves x plus 1 half. Now let's complete the square over here. So half of 3 halves is 3/4. So if I imagine multiplying this out, I'll get my x squared. I'll have x times 3/4, and then another x times 3/4 gives me my 3 halves x. And then when I multiply this by itself, that's going to give me an extra 9/16. So I'm going to subtract 9/16 here so that I don't have that extra term there. These terms will make 0 again. And then I still have the 1 half on the outside. And this is all still equal to y over 2. Let's combine these two together, and then we'll multiply through by the 2 again. So if I want to combine these under the same denominator, I need the 2 to become 16. So I'll multiply by 8 over 8. So that gives me 8 minus 9 gives me negative 1/16. This is y over 2. And so now finally I'll multiply back through by 2 again. So that gives me 2x plus 3/4 squared minus 1/8. Okay, so you could do it that way. The idea was divide by the leading coefficient for x squared to make it easier to complete the square. Totally different thing you could do, obviously related, is let's factor a 2 out of those two terms. So 2 times x squared plus 3 halves x. And then the 1 is still there on the outside. Okay, so now I'm going to complete the square just on the inside here, but everything else is going to be the same. So I'm going to put parentheses, and I'm only going to work within the parentheses. All right, so now that completing the square is kind of the same as up here. I've got x plus 3/4 squared. Again, I got the x squared. I have 2 times the 3/4 x, and then I have this extra 9/16, so I'll subtract 9/16. All still inside the parentheses. Now I'll redistribute the 2. So I've got 2x plus 3/4 squared. The 2 distributes here, giving me negative 9/8 plus 1. 1 is the same thing as 8/8. And so that's what gives me my negative 1/8. So same thing. As I feel like I always tell you, it's good to do it both ways, because it is good to know how to do it both ways. But I guess choose a way that feels comfortable for you and get that one down first, and you can try the other one. Okay, but we're not done yet, though. Remember, our whole goal here in completing the square was we wanted to be able to know what's the point AB and what's the line y equal k, where all of these are, all the points on this curve are the same distance from AB and from y equals k. So let's do that now as a second part. Here, I'm going to copy this all to a new page so we can work. Okay, so remember, the corresponding parts of the equation should be equal. So we've got all these things being equal to each other. So right away, we know that A is just negative 3/4. Let's set up an equation for these other ones. So I know that 2 equals 1 over 2b minus k, and I know that negative 1/8 equals b plus k over 2. Let's go ahead and, what should we do? I guess let's just simplify on both sides. So I'll multiply through by the denominator and distribute. So it'll give me 4b minus 4k equals 1. On this side, I guess let's multiply through by 8. So that'll be 4b plus 4k. This is turning out to be very much like the last problem. So I'm going to write them vertically. So 4b minus 4k. So now I can add them together. So I've got 0 equals 4b. So that means b is 0. If I substitute that in up here, or sure, let's substitute it in there. So that gives me 2 equals 1 over 2 times negative k. So that gives me negative 4k equals 1, which gives me k equals negative 1/4. So we've got negative 3/4 comma 0, and y equals negative 1/4. Let's just pause and think if that makes sense. So negative 1/8 really is halfway between 0 and negative 1/4. Here, let's actually draw the picture a little bit. So where did I say it was? Negative 3/4, 0, and y equals negative 1/4. So we should have an upwards facing parabola, which we do because that's positive. The location of the vertex makes sense. So it passes all the spot checks. So I feel like, it's not definitive proof or anything, but it does feel like that probably makes sense. So coming back here, hopefully the thrust of these problems is clear now. The idea is this form tells us something specific about the parabola. It'll tell us the point AB and the line, which all these points are equidistant from. And so if you can make your equation in a form where you can set the parts equal to each other, you can figure out things that you didn't know before about your parabola. So if my parabola is in general form here, the only thing that's really obvious is what the y-intercept is. Here I've got y-intercept 1. But if I can put it in vertex form, now I know where the vertex is. And then I can also relate the equated parts together and figure out A, B, and K. So that was the idea of this set of problems.